Hi there, and welcome to a Scratch tutorial. In this video, we will be adding physics and collisions to our engine, as well as some general improvements. By the end of the last video, we had finished most of the visual components of our engine. Now we need to start adding features that will help us make a full game. The two most common features are physics and collisions. By the end of this video, we will have a working physics and collisions system for the player, but before we do that, we need to add some updates. The first update will help optimize the engine. Right now, every object calculates the sine and cosine of the camera directions. Since the sine and cosine blocks take up a lot of processing power compared to most of the other blocks, we can make our engine faster by calculating these values at the beginning of each frame in the camera sprite, then storing those values in 4 new variables. These variables will be for all sprites, and we'll name them camera Y direction sine, camera Y direction cosine, camera X direction sine, and camera X direction cosine. In the camera sprite, we'll set these variables every frame after the camera direction variables are updated. In the object sprite, we'll edit the rotation matrix custom blocks to take sine and cosine inputs instead of a single direction input. Finally, we'll swap out the sine and cosine custom operator blocks for sine and cosine variable blocks. When we run the project, there are no visual changes, but the engine can now handle more objects without lagging. For the second update, we'll fix a small bug in the object sprite. Right now, after the project finishes cloning, the original sprite acts as a double of the last clone. We can see this if we use the ghost effect on the clones. While this doesn't cause any serious problems with the walls, it will become a problem when we start adding enemies, power-ups, and other interactive objects. To fix it, we'll add a new variable, isClone, for this sprite only. When the green flag is clicked, set isClone to 0. When an object becomes a clone, set isClone to 1. Now we'll add code to our frame script to check if an object is a clone. If it is a clone, run the scripts. If not, hide the sprite. Now when we test the project, we can see that the original sprite remains hidden and the script is working. The last thing we need to update is a graphics glitch. Right now, sprites often stick out on the sides of the screen. This happens because Scratch limits how far off screen a sprite can go. To fix it, we'll add an if block after the goTo block that checks if the object is where we told it to go. If it is, we can show the object on the screen. If it isn't, we know that it is stuck on the edge of the screen, and we can go ahead and hide it. When we test the project, we see that the script works. Now that this is out of the way, we can begin adding physics to the engine. Right now, the player physics are rather rigid. When a key is pressed, the camera moves, and when a key is not pressed, the camera stops. By simulating friction and acceleration, we can bring more realistic movement to the player in our 3D world. We'll create 3 new variables for this: player X speed, player Y speed, and player Z speed. These variables will indicate how much the player moves along each axis in a single frame. To simplify our scripts, we'll make a custom block for player physics with inputs for acceleration, friction, gravity, and jump height. Next, we'll move all the camera movement scripts to this custom block. Make sure to keep code that is not related to movement out of this script. Here, we'll change the blocks so that instead of changing camera position, key inputs change camera speed. To make it easier to change the acceleration later, we'll use the acceleration input from the custom block. Now the speed will increase when a key is pressed. But how do we slow down? Here's where friction comes in. To apply friction, we'll take away a certain percent of the speed every frame with the code here. For example, if the friction is 80%, or 0.8, it will reduce the speed to 80% of its original value. Finally, we'll change the camera position by the speed. To see exactly how this works, let's take a closer look at what's going on here. If the speed is 0 and no keys are pressed, the friction code will set the speed to 0.8 times 0, which is still 0, so the speed won't change and we won't go anywhere. If a key is pressed, the speed will increase by 5, and the friction code will set the speed to 0.8 times 5, or 3.5, and we will begin to move forward. As the speed increases, the amount taken away by the friction script also increases, until the amount taken away is equal to the acceleration. At this point, we have reached maximum speed, which is 20 here. If the key is no longer pressed, the speed decreases by 20% each frame and the player slows down. We still need to add gravity and jumping, but before we do that, we need collision detection. Now that we have basic player physics, it won't be too hard to add basic player collisions. The idea behind collision detection is to detect when a player has moved into a solid object, such as a wall, and then backtrack the player out of it. Before we start building the script, we'll look at a 2D example to see how this will work. If we have a two-dimensional rectangular hitbox like this one, we can define it with 4 values: left x, right x, lower y, and upper y. If a point lies between these values, we know that it is inside the hitbox. If we add lower z and upper z, we will have a total of 6 values to define each 3-dimensional hitbox. We'll use a list to hold this data, and we'll call this list solid hitboxes. To make this work, we'll structure the list so that each group of 6 items represents one hitbox. For instance, items 1 through 6 are one hitbox, items 7 through 12 are another hitbox, and items 13 through 18 are a third hitbox. Now that we have a plan, we can begin coding. The list should be empty when the project starts, so let's go into the camera sprite and put a delete all of list block at the beginning of the script. Next, we need to make sure that the hitboxes are added in the object sprite after the list is cleared, so we'll use a broadcast block to trigger the cloning script. Now we'll make a custom block to add hitboxes to the list. The if-else blocks in this script make sure that the lower value is added first and the higher value is added second. Now that we have a way to add hitboxes to the world, we'll add one to our add tower script. Next, we'll make another custom block to check for collisions. Ground should be detected at the player's feet as well as at the level of the camera, so we'll add an input for player height, or the height the camera sits above the ground. We need this script to scan through the list of hitboxes, so we'll use a repeat loop. Since 6 list items represent one hitbox, we can get the number of hitboxes in the list by taking the length of the list divided by 6. We'll use the I variable to keep track of where in the list we are. Now we can use a series of if blocks to check if the given point is inside a hitbox. To access each list item, we'll use I plus 1 through 6. Now we'll make a new variable, hitbox detected. If the script finds a hitbox, this variable will be set to 1 and the script will stop. If we reach the end of the script, we know that no hitbox has been found at the given point, so we'll set hitbox detected to 0. Finally, we'll add a universal floor to the world. Now that we have a script to detect collisions, we can incorporate it into our physics system. We'll first set up the collision detection block with camera position inputs and an if block to check the hitbox detected variable. We'll detect collisions along each axis independently, first checking the new X position, then the new Y position, then the new Z position. If the new position is inside a hitbox, we'll move back to the original position and reduce the speed along that axis. Finally, we'll add gravity and jumping. For gravity, we'll change the Y speed by the gravity each frame. The current friction is good for moving horizontally on the ground, but friction when moving vertically should only be minimal air resistance. We'll manually set the friction along the y-axis to 0.99. For jumping, if a collision is detected along the y-axis and the speed is less than 0, we know that the player's feet are on the ground. If the jump button is pressed here, we'll have the player execute a jump. If we try to run the project now, we find that we can turn the camera, but we can't move. This is because the camera Y position is initialized to 0, which is ground level, and so we are stuck in the ground. We can fix this by raising the camera's initial Y position. Now when we try it, we can see that everything works, but the jumping is a bit low. Let's increase the jump height. It's a bit high, but this gives us the opportunity to test the tops of the tower hitboxes. Now let's lower the jump height a bit. And there we are! We have successfully added physics and collisions to our 3D engine. Thanks for watching! We will definitely cover topics like 3D sound and object physics in later videos, and if there are any other topics you want covered in this series, be sure to let me know in the comments. If you enjoyed this video, please like and subscribe, and I hope to see you in the next one.